expect to be very unpopular because all I've been hearing about is tiny house. And by the time we get to the end of my lecture, I'm going to be basically trying to convince you that bigger is better. So it's kind of an ironic thing. I'm actually not just going to talk about energy efficiency. I want to talk about affordable. Affordable housing in general. Now I gotta get back to where we were. Oh, this is interesting.
Oh, yeah, at the bottom.
Right, but that's the PDF. The entire folder just seemed to disappear. Up there. Where's the rest?
The PDF itself?
There we go. Keynote. When months ago, when I had to throw out what I was doing, I said efficiency, and energy efficiency, and affordable housing. But I actually want to give you a bigger picture about what is affordable housing, how it works, and lead up to where what we've been doing, which is some very energy efficient affordable housing. So this is us, Duncan Wisniewski Architecture, and we're 7 to 8 people. We started a long time ago. I don't want to say how long ago. My partner Bob and I, now we have 5 really good young people working with us. And when, a clean, well-lighted place, that's going to show up again at the end. So I'm doing some foreshadowing here.
Michael, are you in Vermont?
Yes, so Burlington, Vermont, and we started in 1985. And basically, Bob and I worked together for a few years. We started working together. Like all young architects, we were doing anything we could, which often turned out to be houses for, second homes for rich people in Stowe, which wasn't really very much fun. And, well, it was fun in a way, but we wanted to do more than that. And so we had a mission to work for the less privileged and to work on not just housing, but anything for parts of society that can't afford a $6 million second home in Stowe. And so really we started out, the first thing on the left was, it was an old flop house in Burlington, which got converted to basically SRO housing. The building to the right of that then became a shelter. The building to the left here was abandoned and also became a shelter. And so we're kind of building our network, working with various people who also were interested in working for the less privileged. But when you think about, like, well, what is housing? You know, the definition of what is a house or housing is actually pretty unusual. If you look at the history, what we think of as houses is not always the way people live. On the left, it's kind of what people often imagine was the mythical first house, wrapping some tree branches together, which ultimately led to the Parthenon in Greece, and then a recreation of the Parthenon in Nashville, Tennessee, some pretty nice big houses in Venice, and then the Follett House in Burlington, Vermont. So the history of architecture is generally looked at monuments and the best things rather than the things for people who maybe can't live there. So when you look at what our kind of definition of a house is, as I said, that single family home is a kind of myth or archetype that hasn't been around that long in a way, and also has become pretty much unaffordable. On the bottom right is a house I did in 1991, 1,900 square feet, $90 a square foot at the time. It's a nice house, but nothing super special, 170,000 K. If you try to do that today, the prices we've been seeing for single family homes are about $275 a square foot. So that translates to $522,000 before you buy your land and put in your road and septic and all that. I recently sold my house and I'm living in an apartment and I want to build a little house, and I keep looking at the numbers and it's kind of like, geez, I think I'd rather go to Italy a bunch of times than do this. So when did sort of affordable, or you might say multifamily housing, really happen? The Industrial Revolution, there was a great need for workers, and they sucked them out of the rural areas and they built these things that were mostly tenements, partially because they were greedy, and partially because there wasn't really an idea as to what multifamily housing should be. The Jacob Riis photo on the left is from a tenement in New York in late 1800s, early 1900s. And it was thanks to Jacob Riis that people really began to understand what the state of housing was. So there was a movement in architecture, both here and in Europe, this was Le Corbusier on your right from Europe, to say that space and light and order are as necessary as bread and a place to sleep. And there was these big hopes that with all the new technologies coming around that they could solve the housing problem. But there was still that kind of definition, like, well, what should we do? So in Germany, in the early 1900s going into the 1920s, there was this movement called existence minimum. And they were basically trying to rationally and scientifically study. It's like, okay, well, what should a house be? What are the elements? What are their basic sizes? And you can see on the right all sorts of studies for like showing how sunlight comes in and different configurations, trying to figure out what is the actual minimum that you need to act as a program for multifamily housing. That was a good thing, but it actually had some bad consequences, as we'll see. So these are two projects that were done based on that ideas, one in Germany and one in the Netherlands. And they were both successes, but at the same time, well, this is a little bit later, another approach was the Levittown and American approach, which was the single-family, automobile-abetted, going to the suburbs and building these single-family homes. And it had its own success for a while. It actually worked. They built these really small, cheap houses, which people could actually expand over time as they got more money. Strangely, on the right, you see two different houses, and it's the same family in front of each house. So clearly, they had been hired to help market these things rather than it actually being their houses. And we also got a lot of attempts at prefabrication and manufactured housing, all of which had great promise, none of which ever really panned out because they were too expensive. And none of them really kind of made the kind of richness of a neighborhood that you see on the left. And so what really began happening is the people in power started saying, we don't have enough money, and we're spending too much money on those people. And so money kept getting cut back. And that whole idea of existence minimum was supposed to tell you this is what the basic needs are. That became the standard. It was like, okay, now we're going to make these small things. We're going to keep shrinking. We're going to keep cutting back. And if we are going to do affordable housing, it's going to be so incredibly as cheap and inexpensive as we can make it. And on the left, this is Pruitt Ego in St. Louis. Not only was it ugly, as you can see on the upper right, but you can see how different it is from the surrounding neighborhood that it was put in. I mean, there's this beautiful context of neighborhoods, streets, and grids and blocks there. And they built this thing that was pretty alien and ultimately had to blow it up. On the right is Cabrini Green in Chicago. Same thing, that was so bad. And it's not just because of the architecture. I mean, there was social problems and issues that are bigger than that. But they knocked it down, and now they're going back, and I think they're almost done. They're trying to replace it with the brick stuff that you see in the front, which is something more of a traditional housing that would create more of a better society than what was happening in these kind of terrible projects that were done. So affordable housing then kind of bears a heavy load. I mean, for us to do it, it's not easy. The money's tough, and the neighbors often don't want it, and there's big struggles. So I like that image on the right of all the snow on the roof, and then St. Francis on the left holding up this building as bearing up the weight of it. So back to us, the heroes, I hope. And what we have done, we were regularly doing projects. This was called the Mermaid House in Burlington, and it's a 9-unit building with commercial on the ground floor. It was an infill site. And that was, back then, we considered this one of our successful projects. At that time, our clients, it was before the energy crisis of 2005, so we kept pushing energy efficiency, but we didn't really get to do very much because energy was so cheap. The Mermaid on the building came about as a way of telling the history of the neighborhood, because the site was a Shell gas station originally, so there's the Shell. When we were excavating for the foundation, they discovered bones of 1812 soldiers. It was actually a graveyard. And we also discovered from the commissary the tin pots that the soldiers had. And the Mermaid's hair has fish in it because Ray's Seafood was right on the corner there, and that was a neighborhood institution. So one of the things that we try to do with our affordable housing is try to have some kind of story, try to add some kind of little extra effort to it, even though it's basically a big, simple box. Now, for some reason, last night the pie chart was there. Maybe this isn't a place for pie charts anyways, and it's not really important. But most people, when they hear that I either do affordable housing or I'm going to talk to them about it, they think I'm going to give them some tricks to make things less expensive. That's a myth. The reality is that actually affordable housing is often more expensive than what developers are doing, because the people who run these things are, they're in it for the long term, and they want low maintenance. After the 2005 energy crisis, they began to learn that, oh, we're paying for the heat in these things, so we need to gradually up our game. And so the way it's made affordable is that they go out, when the federal government got out of subsidized housing pretty much, they did create something called low-income tax credits or low-income historic tax credits. So a bank that's making a lot of money, they can invest money into our project and they get tax breaks for like 15 years. And then we also go out and get some, whatever other grants are available, not we, but the nonprofits who kind of came up out of the vacuum when the federal government disappeared to create housing. So basically, we started bringing a bunch of money into the building fund, and then that takes the mortgage and takes it down to here, and that's how you create affordable housing. It's not the cleverness of the architect or the nonprofit. And their other goal is not just to do housing, but to build communities. So we often are going into sites that are difficult sites, brownfields, et cetera, and trying to repair communities. So remember Pruitt-Igoe. This is in Rutland, Vermont. And that in the center here was a 1970s HUD project that you can see on the right. It was called Forest Park. And it was a total failure. The buildings were falling apart. The day I started the job, there was an article about a drive-by gun shooting in Forest Park. And you can also see how different it is, just like Pruitt-Igoe, from the surrounding neighborhood. It was divorced from the neighborhood. And so it was, of course, not going to fit into the society there if you basically create a road that's separate from the rest and lead people into the site and isolate you from the neighborhood. So the first thing we did is we said, let's relocate the road. Let's connect the road back up to the grid and create a real pedestrian streetscape and do a mix of buildings, lots of duplexes, a sixplex, a fourplex, a 12plex, and actually have some for sale on the bottom, single-family homes. And this was, I think, a good thing, but the problem was, as always, money. So we basically, they said we can't afford it all at once. So we did phase one on the left, and phase one was as per the vision. We did it. It was like everything was looking like everything was going to come out and be perfect. Phase two came along 2 years later. It's like, oh, we're having trouble getting money. So we started diluting things. The buildings, the central green, which was supposed to be the centerpiece, got a little bit diluted. The buildings got simpler. We lost the single family homes. And by the time the third phase came along, all they had enough was to do one 18plex and 2 duplexes, and the rest of the street is being left empty. So it's still an incredible success compared to what was there, but I always feel like really kind of bad that we didn't get to carry out the vision. We didn't really get to finish it as we originally imagined. But what we were beginning to learn with the nonprofits was even though these small buildings were what would help us get permits easy and what people wanted, single family and duplexes and stuff, is because of their surface to volume ratio, they are a lot more expensive than a bigger building. And so there began to be increasing pressure to go to bigger buildings. So this is Harrington Village. That last one was about 85 units. And this was another new neighborhood that we designed in Shelburne. And in this one, we decided, okay, we still want that feeling to connect to the village that's there with small scale stuff. So we did 2 larger buildings and 6 smaller buildings. And that's a way of sort of connecting the scale to an existing village, making the transition, but still getting the economies of scale that you get with our larger building. So on the right is a 36-unit senior housing, and in the middle of the courtyard there is 26 units of family housing. Carrying on with that theme, this is called Bright Street, which in Burlington was often known as Blight Street. And it was in really rough shape. So it was the idea of not just providing affordable housing here, but of doing it in a way that helped to heal this neighborhood. And so they assembled this sort of oddly shaped site of multiple different lots. And when we analyzed it, we said, okay, well, there's a lot of kind of small buildings here, kind of gables. There's a bunch of small buildings here that are actually flat roofed. And this one was nicknamed the 10 Commandments because it was like 10 little things lined up together. And we said, well, what if we kind of healed the streetscape with a gabled duplex here, a flat roof triplex here, so it's almost as if these 2 neighborhood themes are coming and wrapping in to the bigger scale building here. And then to tie them together, we have like an orange element on each of the buildings to make a certain continuity. And by this time, we are actually being able to do things that we weren't able to do in affordable housing before, like ventilation systems with heat recovery and with continuous exterior insulation. So we've been doing this kind of thing where gradually each project we try to sort of bring the energy level up a little bit higher. But we were itching to go further, and our clients have always been like, yeah, but we have to be able to afford it. If we can make the numbers work, we'll do more, but if the numbers don't work, they don't work. So in 1912, I got my passive house certification, and for 5 years I've been like trying to convince somebody to do a passive house multifamily. And Cathedral Square, who does energy efficient senior housing, finally said, if it doesn't cost any more, we'll do it. And so we had this opportunity, which freaked me out because I got very scared. It's like the sublime suddenly hit me, because everybody that I talked to that was doing passive house, whether it was single family or in other parts of the country multifamily, they talked about what a long iterative process it is. Because the whole idea of passive house is you sort of postulate something and say, well, what if we're going to do this insulation? And then you do your energy modeling, and then you, on your team, you have a contractor and you come up with the prices, and it's like, nope, that doesn't work. And you keep refining it and refining it. Well, the way these nonprofits work is they do this long process to get their funding, and once we have the funding, it's like, you got to go now. We need the working drawings in 4 months, and we need to get under construction. So I was really worried that we wouldn't have the iterative process that could take a year long to do it right. But we're in good shape, because this is from Harrington Village. This was a previous building we'd done for them, and a lot of the things that were in passive house, such as the heat recovery, ventilation, pretty high R values and stuff, we'd already been doing. We weren't quite to passive house level, but we were getting there. So we thought, well, maybe it's not such a big leap to do this. Now, the way we got the job was actually a competition. They selected 4 firms and gave us a small amount of money and to come up with an idea to convince them to do the project. And so I took a cathedral as my inspiration for this, which had nothing to do with the fact that it was for Cathedral Square. But what I felt was that if you look on the right side there, a cathedral, what is it? It's really a bunch of very repetitive pieces with a fancy altar and choir at one end. And for economy, a box is good, but also for energy, a box is good, because the simpler the form is, the fewer weird details and joints and junctures that you have, and the fewer thermal bridges, which is a big thing in Passive House. So we said, well, let's just make a box that has the covered parking for the seniors, that has all of the units in it, and then in the front, we'll go crazy. And that's not crazy, but just a little bit crazy. And that's where we will do the meeting room and the common room and the gym and the laundry and stuff like that. It was a very strange site, because you can see it was a field in suburbia of Milton, but it was the first building in their new designated downtown core. So it was our job to sort of create a pedestrian-friendly streetscape that would set the tone for this whole thing. So what we did is, if here's the street, and we said, well, here's our cool stuff, and we've got a courtyard, an entry, we've got a big front porch, and then the simple stuff is in the back. And we bring it up, even though it's the suburbs, we're going to bring it right up to the street and hopefully create a good streetscape. So back to the tiny house versus big is better. What we discovered when we started, because everybody in Vermont who had been doing Passive House had been doing single-family homes, and they were saying, well, we need R of 100 in the roof, we need R of 60 in the walls, etc. It was a crazy, crazy thing. But the surface to area volume of these bigger buildings is so efficient that we were actually able to, whereas our typical standard now for high efficiency housing is 2 inches of continuous foam on the outside, we were able to do it with 3 inches. And so suddenly, the fact that they had already been doing the energy recovery ventilators, and that we didn't need that much more insulation, and a few other things, we actually were able to build this for, we'll see the numbers later, but it was more or less on budget. So this is what we did. It was just, like I say, on the top, that's the box. So we had parking below. We had a concrete and steel frame because of energy, or not energy codes, building codes. And then we just had a big box with 2x6 studs and a 3-inch insulation panel on the outside. And then in the front of the building where we have the meeting room, it's like, oh, well, the meeting room can now have a 12-foot ceiling, so that before we've been cramming them into the box and we were only getting an 8-foot ceiling, and it never really felt like a place where society could come together in these and create a good sense of internal neighborhood. The foundations, the amount of foam that goes into a Passive House foundation is just unbelievable, and it still gets me. Part of my strategy was by having, I don't know, 70% of the building be on-grade parking with a box over it. We had very little in the floor plan of this, but we still needed a lot of foam insulation, which is just not a lot, but we're trying to figure out a way to not do foam. This was actually the last project that we did with XPS foam. Now when we have to use foam, we only use EPS, which is better environmentally than the XPS foam. But I kept fighting with my energy model because I was like, I don't get it. Why do we need this much? And it's not just for keeping energy loss in. Passive House is a lot about healthiness, and they don't want unhealthy air, they don't want mold, they don't want things growing. So really, when you can see these weird colored things on the side, they do these therm models that show that they're trying to keep the surface temperature of the inside above, I think it's 52 or 54 degrees, because below that is when you can begin to get mold growing. So it's not just for the pure energy loss, it's to protect how you prevent mold.
Sorry, but you said how many? What was the dimension for venting?
Oh, 54 degrees? To try and keep the internal temperatures at 54 degrees, which prevents mold.
Even at
Even, well, it's a slab on grade, so people are living and yeah, so, right. So this is just more details on the wall showing, we said, hey, because the other thing is if the numbers weren't gonna work, we had to go back to conventional. So I couldn't design something that was like experimental. It's like 2x6 structure and fiberglass insulation. We got a zip air barrier on the outside and then our foam insulation. And you can see it in there, the green zip and then the foam panels going up over it. The flat roof is a real problem. The simplest way to do it, it's not a problem if you do it the simplest way, which is you put your structure up and you put 10, 12 inches of foam on it. And that was creating about a huge financial burden on the project, as well as, once again, using that much foam. So you can't vent a flat roof, so we couldn't just have an airspace above. And we couldn't do a pitched roof here because the site was so tight that there were sidewalks right along with the elders. We didn't want ice and snow falling, and we also needed places to put our air source heat pumps and condensers and solar panels. So we hired a consultant to do some kind of special model. I think it was a third model. And we finally determined that we could spray some foam on the underside of the deck in different thicknesses because the structure was sloping, so it was changing its thickness, and then we could put fiberglass underneath it. But it's about an R70 roof. The windows are challenging. We finally got to use tilt-turn windows from Europe for the first time. Pretty much everybody hates them, so we're not going to get to use them again. They don't like they feel that when it's in tilt, they're not really getting the benefit of an open window. And turn, especially, you can see on the right, that's the bedroom window. It was originally 2 smaller windows, but for budget reasons, it's much cheaper to do a single, because of all the hardware costs, you're not doubling it, so you do a single window. But when you open that thing, it just felt like people thought they were going to fall out. So the windows were great. I kind of really like them, but I don't think we're ever going to get to use them again in an affordable housing project. The garage was a problem because we had these steel columns encased in concrete, and they were just like radiators, taking all the heat out potentially into the world, into the landscape. And my structural engineer came up with a clever idea on the right. You can see, instead of just having a single column, he made a big column and a little stub column. And in between that, right in the middle of the insulation, we put, it's called Armatherm, and it's a little thermal break material. It's only like an R2, but it just creates enough of a thermal break to prevent all of that steel from just like sucking not only heat out, but once again, condensation, which could then develop mold over time. Now, once again, everybody that had been doing passive house had been doing single family. They didn't have to deal with some of the surprises that we eventually came up with, of which there are no obvious passive house solutions. If you have fire ratings, you need to use a metal door and frame with a rating on it. And so I finally found one that had a thermal break in it. And then when the shop drawings came through during construction, I looked at it and said, oh, the thermal break doesn't have a fire rating. Why is that? And they're like, oh, well, we were just joking in our catalog. We haven't actually had it rated yet. So we couldn't use a thermally broken frame, and we just had to take that hit. Luckily, there was only 4 or 5 exterior doors that were metal, like in and out of the garage and stuff. And we had over-designed our energy model so that we had room to take a hit in a few places. The other thing that is just impossible is the trash chute. Most affordable housing that we do that's family, you have to take your trash out to the dumpster or wherever it is. But the seniors, they need to go onto their room and drop something down the trash chute. As I started calling trash chute people around the country and told them what our problem was, there was just this big silence. And then they would start laughing because they were like, nobody's ever asked this question before and we don't care about it. So we wrapped the thing in as much foam as we could, but the bottom is always open. So it's like you basically have a wind tunnel and the top is always open for code reasons. So you basically have this wind tunnel going through, And the doors on each floor where you put your trash in are just not very, they're not very tight. So that's something that we had to accept and couldn't do anything about. Most of the time, if you're doing energy efficient construction, you know that the dryer vent is one of the worst inefficient things that you've got. And in Europe, they've developed condensing dryers, which aren't very good, but still work. It takes a lot longer. But there was no commercial models. And so we had like 4 or 5 dryers, and we were trying to figure out how to make that work. And what we finally came up with was an interlock that basically the intake goes directly into the dryer, and there's an interlock there, and only when you turn the dryer on does the interlock open to let air in. So it's not as tight as a really good door, but nevertheless it does a pretty good job. And the other thing that we discovered is we were really good at our airtight and insulation on the exterior, but when you do passive house, you also have to meet Energy Star, and you actually have to do airtightness between units. So your party walls also need to be, not to the same level, but there was a couple areas where we just didn't pay enough attention, and we had to go back and spray extra foam and stuff like that. But that was a lesson learned. Our systems are basically, we have a big ventilator that provides fresh air and exhaust it with a heat recovery and energy recovery unit in it. And we have air source heat pumps for both heating and cooling. And this is one place where we actually had a problem. After the building was finished, it wasn't performing as expected. And we brought experts in, we did a lot of research, and we finally discovered that the heat pumps were basically oversized because there's only 600 square foot apartments, and nobody was really making heat pumps that were sized for units that small. The manufacturer's literature, they didn't tell the truth about a lot of the stuff. They made it sound that you could ramp these things down. Turned out you really couldn't, and they were essentially running all the time, and we were using twice the energy that our energy model projected. So we just finished, in the 2 years that it took to work all this out, they finally are making heat pumps that are small enough. And so we actually had to replace all the heat pumps. We did a couple tests in advance, and when they put the right size heat pump in, the building is performing as per the model. But until then, it wasn't looking good. And I think it was just last week that they finished the last one. The other thing we didn't realize was we'd done heat pumps for air conditioning only before, and we put them on a flat roof, and we never saw them. Here you can see clearly in the picture how you can see them. And because if you're only using them for air conditioning, you can put them right on the roof. But in Vermont, if they're going to heat also, they have to be 18 to 20 inches in the air for the snow to build up under them. So that was a big surprise. That I haven't looked at the new ones, if they're smaller or not, but that was another big surprise. Construction is also an interesting process, because when you're doing a small building, probably with a builder who is very simpatico and is experienced with passive house or similar, they understand the details, they know what to do. Riark, who was our construction manager, had never done one of these, but they dove right into it, and they did a great job. But there were some surprises. All of the wall panels were prefabricated in Canada. And so we checked them. It's like, yeah, 20 feet, 20 feet, 20 feet. And then we get on site and they build them, and you can see in the center, there's like a 1-inch gap between the panels. And we're like, well, how are you going to seal that? You know, well, it wasn't that hard, but it was more a question of why. Well, the panelizers figure, I'm building a building that's 150 long, I've got to build in some slough for mistakes, or if things grow or shrink or whatever. So they build in, their shop drawing doesn't say this, but it's a 20-foot panel, but they only make it 19 foot, 11 and a half. And so by the time you put these things together, you have all these gaps that we then have to go back and very carefully air seal. So money, it actually worked out pretty well. And I think exercises like this in some ways are futile. You can never really suss out all of the adds and extras. But ultimately it came out to be 3% more than a standard affordable housing project. And So, I mean, we were pretty proud of that. They were pretty excited about it. And this is an interior just to kind of show you that, yes, we can have some nice spaces with this concept of pulling the nice things out of the 8-foot tall ceiling box. And I don't know why they named it Elm Place, because there was no elms there, but we did find in Richmond, the next town over, a 500-year-old elm that was coming down because it was dead. And the guy who took it down, he takes the slabs and he sells them, and he donated a 500-year-old piece of elm to put in our lobby. So it took me 5 years to get a passive house. I've been trying to get a bocce court into a affordable housing project for even longer. We would design one into every project, and then it would always get value engineered out at the end. And so near the end of the project, I get a call from the 3 developers, and they're all like, "Michael, we need to talk to you." And I'm like, "Oh, what did I do now?" And they said, "We got a little bit of extra money, and so we want to build a bocce court." And so we got to build a bocce court and a pergola, and I had to go out there with a bunch of Cinzano and teach everybody how to play bocce. So, kind of lessons learned is, and the future is, I don't think any of our clients are going to do a passive house again. But they've all been pretty impressed with it. They're not into certification, so what they're in is performance. And so pretty much everything we're doing now is kind of passive house. It's just not going quite all the way. It's not putting as much foundation insulation, and it's working well. But that sort of idea of a 2x6 with a couple inches of insulation and triple glazed windows, not the tilt turns, but there's some fiberglass people all over the US that are making some really competitive windows, and the good ventilation, and a few other tricks with the trash chutes and stuff like that. And so we're doing these big buildings that are performing nearly as well as a passive house, and we're not doing it with that big of an uphit because, once again, that surface to volume ratio of a large structure is just helping us so much. So this was a building finished like 2 weeks ago in Burlington, the Laurentine, and there's a picture of me with, took me a long time to go to Canada and find Laurentine beer, but the staff named the building, and the head of the nonprofit, when she found out the name, she started laughing because she grew up in Canada, and said, "Yeah, Laurentine's a Canadian beer, and it's not very good." But this is an example of, it's basically a pretty big U-shaped box. It's 76 units, so it's 89,000 square feet. And we've learned enough lessons with air tightness that we had a commissioner help us with our envelope commissioning, and at the end, this is the tightest building they've ever tested in I think, not just Vermont, but because they're in the Northeast. And we're actually, passive house is 0.05, and we're at 0.017. So we're 1/3 the amount of air leakage as a passive house in this huge building. And the contractor was very detail oriented. I don't think we could get, the same details would not come out the same in most other buildings. So one of my struggles with affordable housing is that our clients are pretty risk averse. I mean, somebody who's doing a single family home might take a chance because it's cool and they want to do it. But they don't really want to take chances, so it's hard. And at the same time, they're saying we need, things cheaper and better. So in 1943, the U.S. government found out that the Germans were really close to developing a jet, a fighter jet, and they knew that that happened. It would change the course, could change the course of the war. And they also knew that the kind of bureaucratic system that had been put in place, both with the Defense Department and the aerospace manufacturers, wasn't really all that amenable to innovation and taking risks. So somebody came up with this idea based on a little Abner cartoon of a Skunkworks. And so the aerospace people, there was people who they would work their day job and then they would go out at night and work and invent things. And they started coming up with all sorts of amazing things that helped the defense industry and our aerospace industry, and eventually could filter down into the regular world, those technologies. And so I've been advocating for a while that affordable housing needs to have a Skunkworks. We need to have something where we can take some risks, you get some funding, you do a small project, you know, fourplex or something like that, where we can do some experimentation. So far, nothing's happened with that, but I think if we're going to try and change and continue to develop affordable housing, we're going to have to do that. So the last project tonight is our own kind of Skunkworks, which hasn't been built. But it's probably a year and a half ago, a person in Burlington came up with the idea of pairing various architects with various either homeless or almost homeless people to sort of say, hey, what would you want to live in? Not a mansion, but like, what are your needs? And I got paired with this guy named Stephen, who imagined that he could become like almost like the mayor of a little tiny house community with his, and then you can see in the bottom right, yeah, this would be his house. These would be like tents and tiny houses for other homeless people, and this would be a common building where they could take showers and have a communal kitchen. And it was actually a piece of land owned by Burlington. And so what I came up with as sort of my experiment was to say, well, what if we just put some columns in the ground and some beams, and we just took SIP panels, like a 12-inch SIP for the floor, 8-inch for the walls, 12-inch for the roof, and kind of made a thermos bottle for him. So that would be really inexpensive to heat and cool. And that bar is really, it's got a bedroom, a kitchen, a bath, and a little workstation for him. But he also had this dream of like a room with light in it where that would be totally uncluttered, because he was a kind of cluttered guy, where he could go and dream and write and try and come up with things to not only shape his own life, but help other homeless people. So this was our little Skunkworks project of this little box with a little tower where he could dream of the future. So I started out by saying that the lecture's title was A Clean, Well-Lighted Place, which is what I imagine that we do for affordable housing. We're not trying to do any fancy aesthetics, although we try to put little things into each one. But A Clean, Well-Lighted Place is a story by Ernest Hemingway. And it's about two waiters in Spain, and it's late at night, and the young one wants to close up, and because he wants to go home and make love to his wife. And the other one is like, no, somebody might need us. We need to keep the place open. And our place is special. It's clean, it's well lit. It's just the kind of place that somebody on a dark night, late at night, could use a helping hand. And so that's how I think of our work, as providing a clean, well-lighted place. And the one on the right is in Madrid, where I happened to visit several years ago. And it's called the Cathedral, and it's a clean, well-lighted place, and I went there every day while I was there. Thank you very much. Questions?
I just wonder, regarding the concrete with the foam insulation issue, are you looking at a recycled glass product called Corridor?
No, but we just used one called Glab. Yes.
Called what?
Glab, which is made from recycled glass, and it looks like little pieces of lava, but they're very light, and they are, I think they have an R of 2 per inch or something like that. And Arthur in our office, who's our sustainability coordinator, he just is finishing his own, he bought an old duplex and he added a unit on, and he used gravel in that foundation. And they, right now, for his, it came from Germany, but they are about to open a plant in St. Albans, so they're going to be making it locally.
Oh, fantastic news. Yeah,
So-
because I know Corridor, I think it's in Canada somewhere, I
Okay.
forget exactly where, but I just came across the product and I thought it was fascinating
Yes, I think
as a
so, yeah,
concrete
it's-
alternative.
it was expensive for him. It was more than foam, but it's that would be a thing where you'd be committed and you could do it.
Right.
We've been thinking more and more, not just about energy, but about carbon in our office. It's like how to do that. And it's sort of like, I'm maybe designing a house for myself. And I don't know if I can ever do it, but I just recently decided, you know what, I'm gonna make it a little bit bigger and have storage in it and not have a basement, because trying to insulate a basement and all the things that go along with that, and all that extra concrete and all that is just not good. And I'm probably gonna do it out of all cellulose as much as possible. That's the plan right now. Double walls with a vented cellulose roof.
Yeah.
So,
I'm about to build as well, and I don't want a basement.
right.
It's slab on grade, or maybe recycled glass on grade, who
Yes.
knows, you know?
Yeah. One of you have one?
I was just telling you, it was a great presentation.
Oh, thank you.
You know, I assume all those multifamily housing projects had water and sewer provided by the
Yes.
municipality.
Almost all of our stuff does. I'm working on one in Bristol now it's a renovation of a 1990s project, and that's a septic and well. And boy, what a pain that's been with the septic and well and all that. But, yeah, I mean, the sort of underlying philosophy of all of these nonprofits and the people who fund them are basically, you're not just making affordable housing, you're building communities. And so you can't put this out in the wilderness. People need to be near community facilities, they need to be near mass transit, walk as much as possible. So everything is pretty much city, town, or village for the most part, which all the good sites are on in those places for the most part. So the land costs and development costs can often be high, but that's the standard, yes.
No, just that one sentence sort of sums up a huge challenge for us.
For you, for all of us, or
No, well, in this community.
in this community here, yes.
Yeah.
Yeah, it is.
Water and sewer, water and septic.
Right. And the other thing that's like, the fracking has brought natural gas price down so much that it's really difficult. Like you say, what's the payback to go from 2 inches to 3 inches of foam on our exterior wall? It's like 70 years. So it's like, you save $29 a year. Well, yes, that's true, but the frack gas is not good and it's not going to be around forever. But most of the places that we go also have natural gas. Oh, and here's another thing, just a funny thing. Act 250 requires you usually to add EVs for your EV cars. And so we just started doing this, and so we added 4 to that Laurentide building that just got done. And they're level 2s, but we just put them in, and when the project was done, the owner was like, well, how we charge people for using the electric? And it was like, oh, so that opened a whole can of worms. Unfortunately, on this project, we can't. I mean, if we would have thought of that, and if they would have thought, we could have set that up in advance. You put your credit card in. But in the research, we talked to Burlington Electric, and they're like, oh, well, if you're charging during the night and you exceed your demand rate, you're going to be paying, instead of like 10, 20 times the kilowatt. So suddenly you could be getting charged these demand rates, and we calculated it out, and they could spend, for 4 of these things, if they were running 12 hours a day, it would be almost $30,000 a year. So it's not only the cost to the affordable housing purveyor, but what if everybody started doing this, and Burlington Electric Grid, who will give you $2,000 if you buy an EV, but yet they don't want to grow. So if suddenly 1,000 electric cars were getting charged in Burlington, it's going to really affect the grid. So it's a really kind of a nutty problem that we don't quite know how to solve yet. And I did mention almost all of these buildings do have photovoltaic panels on the roof.
Have what?
Photovoltaic panels on the roof. And the way the nonprofits work is on bid day, we have to be on budget for them to get their funding. So we take a lot of things and we put in our wish list. And then as the project goes along, and hopefully we haven't made mistakes and stuff, out of the contingency, then they say, oh, we're gonna add 20 kilowatts of photovoltaics. Oh, we're gonna put gold-plated bathroom fixtures in. Well, not really, but, you know, things like that. Well, we're done anyways. So there's like, it's a constant process of surprise and discovery. Just when you think you've learned something and you got it down, then you're finding some other big surprise.
So what are the conversations about the living square footage that these units, in terms of, I mean, are people comfortable with continually reducing that square footage?
Well, yes and no. The pressures are, for a while, we haven't been reducing it much, and the building is the buildings are complicated. There's a lot of geometries, and I keep telling people, because people always say, well, what's the first thing you think of when designing housing? They imagine I got some kind of visions about gables or whatever. The first thing I think about when approaching a project is parking, because parking drives everything, including not only like, I mean, do a beautiful building and you surround it with asphalt, well, that's no good. You build a underground parking garage, which we did on Bright Street, so you don't see any parking at all because the site was so tight. But that creates a geometry with guides and units. It's a 62-foot wide building, 5-foot corridor, so you have about a 28-foot depth of your unit. Well, to put a living room and a bed, you need like 12 foot. So you got 24 by 28, you're suddenly up to close to 1,000 square feet. And it's like, well, a unit can be much smaller than that. The other thing that we find, we've struggled to put enough windows in. When I go back for the 1-year inspection, everybody always has the curtains closed. I mean, they got these, it's like nobody likes windows. So we could save money on windows. And and nobody has dining room tables. Everybody eats sitting on the couch watching TV. So you could shrink your unit and just have something very small. But we also do work for a for-profit developer in Burlington, and a lot of units, and he's going to these studios, and he's looking at like 400 square foot units with common space on some of his buildings now.
Have you done any projects with, I guess there's code issues probably, I don't know if your minimum square footage, but I mean cottage type things or small houses, and
well, the only-
imagine that's not as economical to build.
It's pretty
as an
tough.
apartment.
It is pretty tough. Yeah.
I can tell you a lot would prefer to have their own little
Oh, for sure. Yeah.
four walls.
Yeah. No, that's what people dream of, and yet there's no funding for it, and it's awfully difficult to sort of say, I've got this little thing in town, there's a piece of land, and I could put 40 units on, but I can only put 12 tiny houses,
Right.
type of thing. So it's a cultural and it's a resource thing, you know, to sort of say, well, the energy and economics argue for big. That doesn't necessarily mean that's the right thing to do, but I think you have to take that into account, and when you start thinking about your what you're doing is that, yes, I have this dream of a tiny house, and it's actually more expensive to do that than it is to do a big multifamily. And then you have to decide where to go, and I think there's room for both, but
Having lived in apartment buildings, I can tell you so many people don't like it.
yes.
Yeah.
Yeah.
I mean, they're beautiful buildings, I'm not saying
Right.
that it's, what they're doing is not beautiful, it's just, more efficient.
Right. But these things,
There is a yeah.
there's waiting lists of 100 people. That doesn't mean that they want to live there. It means that that's maybe their only option, but it's pretty amazing like that.
What are the rents like in that?
Well, they really vary because, you know, there's always this complicated thing where there's usually several levels of rent, and then people have to come in and they get pre-qualified. It's like, oh, well, you qualify for the biggest subsidy, you qualify for the least, but a market rate apartment, like I'm living in a 1-bedroom apartment in Burlington now, and it's $1,600 a month. And it's a decent one because we designed it. But, it was actually my partner who designed it, so it's even weirder for me, like, I didn't design it, it's my name's on it.
What's the square footage?
It's about 875 or 900 square feet, because it doesn't have parking under it, so it's a little bit not driven by that geometry. So I think some of these run from anywhere to like 700 to 1,200 in Burlington. They might be less, and it's also based on the community too. Like if you're building in, I know we didn't do it, but I know they did one in Bradford, which is a rough economically community, and I think they might have been less expensive there. Okay, thank you.
Thank you.
Thank you for coming.